So, yeah, okay, so we're going to get started. So, the agenda for today is first, we're going to go over how 3D printers work, and then we're going to go over choosing a printer, and then we're going to do like a quick overview of the CAD design process. And I'm going to quickly go over what TinkerCAD is and how it can be used. And then we're just going to start working on Autodesk Fusion 360. And for Autodesk Fusion 360, we're just going to make two things. We're going to make like a trap sphere and like a cube cage thing. And then we're also going to make a hexasphericon. And I'll go over what those are later. So the first two parts, like this first bit, like the explaining and stuff, is probably going to take the first half of the class. So, yeah. All right. So basically, um, how 3D print. So there's many different types of 3D printers that use many different technologies and techniques like laser and like sand and stuff. There's a lot of types. So we're going to be going over two main types of printers, filament printers and resin printers, because other than these two printers, all other printers cost like currently as of like right now costs like way over like 1,000 to like $10,000. So there's no way we're going to use it, you work with it or use it like within the next like few years reasonably. So usually if you're gonna like get a 3D printer, you're either gonna get a filament printer or a resin printer. So I'm gonna go over how both of these work, and then their advantages and disadvantages. And then I'm just going to go over choosing a filament printer because I haven't really done the research into choosing a resin printer, and I also don't really recommend it as a first starting printer. So first, we're going to go over how resin printers work. So there's three main types of resin printers. So mass stereolithography, so MSLA, stereolithography, SLA, and digital light processing, DLP. So it's very simple how they work. So I'm just going to go over how an MSLA printer works. So basically, you have this vat or container of resin, as shown in the first picture, and it has a clear bottom. And then the resin is basically this kind of like gooey liquid thing. And basically, the resin cures or hardens when it is hit by UV light. So, how the MSLA printing process works is first you have this vat or like container of resin with a clear screen at the bottom, which allows UV light through. And then you put this on top of a LED UV light screen and it has this like masking screen that masks off the parts you don't want to cure. So basically, how it works is you want to cure it will cure it layer by layer, and each layer will build on like a 3D model structure. And so the third image is kind of how it looks like when it cures the first layer. And the last image, bit hard to see, but basically it's like in the process of like building it up layer by layer. If you want to get a more in-depth look, you can later search up a video of a resin printer working. And basically, you use the LED UV light to cure it, and then you also have like a mask like screen to block off the parts you don't want to cure. And so basically that's how an MSLA printer works. And so how an SLA printer works is you just, instead of having like a mask to block a screen full of LED UV light arrays and stuff, you just have a single laser that cures it line by line and then slowly builds it up layer by layer. And then digital light processing is very similar to MSLA, but instead of a LED UV laser, you just have a projector without masking anything off. The projector just projects an image, so it just lights up the certain parts that you want to cure. And so basically out of these three, MSLA is the best because SLA is like just a laser, so it just does line by line, so it's going to take more time. And digital light processing is usually a bit faster, but digital light processing, because it projects an image um, rather than blocking, masking parts off, it's a little bit pixelated when the prints come out, so it's not as like high quality and stuff. So the advantages of resin printing are details and accuracies. So resin printers, compared to filament printers, are like 20 times more accurate. They can go to like 0.05 millimeter uh, um, accuracy, and also they're a lot stronger because you're curing the resin, you're basically fully melting it. So usually it's the strength between each layer, because you're doing it 2D layer by 2D layer until you build up an entire 3D model. Usually the strength between each layer is also a lot stronger for resin printers. And because you're doing the whole layer at one time, rather than like a line, like drawing a line, you're just making the whole layer, curing a whole layer at a time. It's also much faster, because especially for bigger prints, because it does the entire layer at once. Um, so then there's the disadvantages. So resin printers, although buying a resin printer can be as cheap as like a normal filament printer, in the long term, resin printers will cost more. Resin itself, the gooey liquid stuff, you need to replenish it, and it costs $50 per kilogram, 35 to $50 per kilogram. In contrast, like PLA filament costs like $20 to $25 per kilogram. So it's a bit more expensive. And then resin printers also don't have part infill. So basically, when you print something, a filament printer, like say a cube, you don't have to print it completely solid. You can have like an internal structure, like a grid structure or something else on the inside to support the cube. So that way you save on a lot of filament, and it only takes up like 10% of the internal space. But in a resin printer, you either go fully solid or fully hollow, because right now companies are still trying to figure out how to make a part in an infill structure, like an inside structure. And so you're either going to have to go fully solid, which wastes a lot of material, or a fully hollow, which is a pretty weak part. And also for fully hollow parts, you need two holes on the part, one at the top, one at the bottom, so that you can let the resin, the trapped resin inside, leak out. So it's a lot of work to make a hollow part on a resin printer. So most of the time, you're just going to have to print it completely solid, which is going to take a lot more resin per print than it would in a comparable filament printer. And then there's also post-processing. So there's the safety involved with that, and also extra equipment. So uncured resin, which this gooey liquid thing, is not safe to touch with bare skin. There is like touching it, like it doesn't have any like direct effects at first, but it actually like changes your immune system slowly over time. So touching it a lot, like over a few months or sometimes a few years, will change how your immune system reacts to the resin, kind of like an allergic reaction a bit. And basically, at one point, if you like touch it with your bare skin too much, um, basically at some point, like even a whiff of it can send you into like seizures or like some kind of like terrible reactions. So you definitely need safety equipment, like special gloves whenever you're going to touch uncured resin, like when it's still liquid, or even semi-cured, like when it's partially cured. And you're also going to need a respirator when breathing with like volatile organic compounds filters. So you're going to need a lot of safety equipment. And then also, after you like directly take it out, like in this third image, there's still like uncured resin dripping off of it. And it's actually not fully cured either because the UV light usually isn't strong enough to fully cure it. So basically, after you take it off, you need to clean it, you need to clean your print, usually with isopropyl alcohol or some other type of alcohol like ethanol. And um, after you clean your print, you also can't dispose of your whatever you use to clean it down the drain or something. You have to dispose of it as waste because, like I said earlier, uncured resin has terrible effects on your immune system. So it's not safe to just dispose down the drain. And then the other thing is, since it's not fully cured, you're going to need to put it under like intense UV light for a few minutes on all sides just to make sure it's fully cured. And you can't do this under the sun because the sun has multiple types of UV light. This gets pretty complex. So the sun emits UVA, three types of light: UVA, UVB, and UVC light. And what cures the resin is UVA light, but the sun emits a lot more of UVC light, which actually damages the resin. And so normally you want like a UV flashlight or like a UV light enclosure to cure it because that would and because those usually only emit UVA light and they're a lot they will actually make the part a lot stronger, while the sun could make the part even weaker. So yeah. So does anybody have any questions about resin printers? It's a lot to go through. No? Okay. So we'll continue on to filament printers. Um, so filament printers are usually FDM or also known as FFF, fused deposition method or fused filament fabrication. There's multiple names for it because some companies patented the name FDM. And so now most companies use FFF now. So basically, filament printer is pretty simple, as you can see in the diagram. Basically, you have your filament, which is just a string of plastic, and then you have an extruder which pushes the string of plastic into a heater, and the heater melts the plastic. And so that way the plastic can be extruded as a thin line from the nozzle. And by drawing a line, you can basically draw any 2D image. And by drawing a 2D image, you can draw a bunch of 2D images and stack them on top of each other to create a 3D model, which is what a filament printer does. It basically slowly draws 2D images to create a 3D model. So filament printers are pretty simple concepts. So yeah. And then so the advantages of filament printers are their cost because of how simple that process is. Filament printers are the like most popular and cheapest printer to get out there right now. And because of how cheap they are, they're also the most popular. Like there's been so many filament printers and so many there's a lot of experts in the field of filament printers and so many people who have like used filament printers. So you can always like easily get help for like filament printers. And so that can be counted as an advantage. And then also your process is so easy to observe. So basically, filament, like how your printing process just happens right in front of you. And so you can just observe it and see if it fails you can know very quickly, and you can also see like how it fails and stuff, as opposed to resin printer, which has a like blocking, like this container that blocks your view from the first part of the print. And that's because you don't want the UV light that's used to cure the resin from like just scattering randomly. And also, it also needs to contain the resin. So you can basically have a better view of your filament print, your print file it's going. So that's another advantage of filament printers. And then, so the disadvantages is layer bonding. So because you're just laying like filament, you're just laying melted plastic on top of other plastic. It's not very well held together between layers normally. So it can be a lot weaker between the layers as opposed to the actual filament strength itself, like down to half as strong, which can be very bad for structural parts. And also small details, the nozzle like size usually doesn't get very small. You can only print reasonably well 0.1 millimeter accuracy prints. And so resin printers can go down to 0.005 millimeters, which is 20 times better. So that's another disadvantage of filament printers. So does anybody have any questions about filament printers and how they work?
So the fuse deposition and the nozzle thing is sort of like a hot glue gun, right?
Yeah, basically it's a hot glue gun. Yeah. So yeah, people have basically used hot glue gun to plastic to try and print, but yeah, it's kind of like a hot glue gun, except for it does it automatically. Okay. So next we're gonna go over choosing a filament printer. I didn't do this for a resin printer because I haven't really done the research into resin printing, and also resin print. I don't recommend resin printers because of all the safety stuff and all the processing. So there's these are the important things you want to look at when choosing a filament printer. So you want to look at the build volume, which is a very obvious thing to look at when like how big of an object can it build. And usually this is another kind of disadvantage of filament printers. Their maximum build volume is usually around 300 by 300 by 300 or so, because filling up to, let's say, a 200 by 200 by 200 volume build can take just filling it fully compact with filament, like no infill, um, just solid, just like a solid cube, can take weeks to do because filament printers actually aren't that fast for big, especially big prints. So so if you have any bigger build volume, it's just going to take way too long to print, and your the chances of failure are so high that you're not like one out of like every like few prints are going to work, and you're just going to waste a huge amount of filament. So usually the build volume is pretty limited to like 300 by 300 by 300 maximum, and even then it's a big stretch to print things that size. Usually most people just print things about 200 by 200 by 200 at max. And so the next thing we use to judge a printer is extruder type. So there's two main types of extruder: direct extruder and Bolden extruder. So basically the one we looked at earlier was a direct extruder. Basically the driver gears that push the filament through the nozzle are directly on the extruder like part, the part where the extruder is basically the part that contains the nozzle and both the nozzle and the heating block. And basically the direct extruder also has the part that pushes the filament into the heating block and out of the nozzle. And then a Bolden extruder has the pushing part, the part that pushes the filament on the side rather than on the extruder itself, because and then it pushes it through this like PTFE plastic tube, and then it can extrude it out. So the difference between a direct and Bowden is that because if you have a direct extruder, like you can see here in this picture, it's pretty complex to design it to get it to fully work. And so it's going to cost like a lot more to use a direct extruder. And so most like budget printers use a Bowden extruder because it's a lot simpler, because you can just have you can have your motor drivers just on the side here. And then, but then the advantages of the direct extruder are the jams are a lot easier to clean up because the filament path is just very short, while here it's like all the way through a PTFE tube. And also you can print more exotic filaments like flexible filaments through a direct extruder, while through a Bowden extruder, they'll get caught on the plastic tube. Does anybody have any questions? No? Okay. All right, so continuing on. So then the next thing to determine what kind of printer you want is the bed type and bed leveling. So there's two main types of bed usually used, flexible and glass. You can use a lot of other stuff like paper and cardboard and wood and some other stuff, but usually most printers nowadays just use a flexible magnetic, like PTC or something coated bed, and others use glass. And the advantage of a flexible bed is it's a lot easier to remove prints from. Um, you can literally just take the bed off and then remove it like immediately. It takes like 30 seconds. But then glass beds can sometimes be a lot harder to remove, and you always feel like you might be breaking your part when you remove something from a glass bed. So usually a flexible bed is better, but a glass bed works completely fine. And then the other thing about bed type is whether you have a heated or non-heated bed. Heated beds are especially important for more exotic materials. So most normal printers just use PLA, which works completely fine on normal non-heated beds. Um, and then other than that, there's some more exotic like plastic materials that can be a lot stronger or more flexible. And those will need like heated beds, but you're fine with a non-heated bed in this case. And then the other part is bed leveling. So you want to make sure your bed is completely flat, like so that you can build your print up like really nicely. And so there's usually two main ways to make sure your bed is leveled very flat. Um, the first way is just to have a build plate and these kind of knobs with springs on them, and you can adjust each of the four corners. That's the manual method, and it's also a lot cheaper. The second method is just to have like a bed and then use a sensor to sense the height of the extruder from the bed. And basically, you don't really care whether the bed is completely flat or not. And so usually the auto leveling is the better option to go with if you can, because auto leveling allows for you, like in case there's like a defect in your bed, like you like broke a part of it or something, it can make sure your print sticks very well to your bed. But manual leveling is completely fine. It's just a little more maintenance, and but it also only works on like smaller printers. So yeah. So does anybody have any questions about this? Okay. Someone asked me which printers do I recommend, and I'll go over that later. Yeah. Okay. So next part that's good for determining a 3D printer is the movement system. So usually 3D printers move using what's called the Cartesian system. So just an XYZ axis that moves it around. And there's also the delta system, which has these, because you can determine a point with like any point in like space, 3D space, I think, with like three axes of movement. So you can use the delta thing. But this type of movement system works completely fine, but it's a lot more complicated than the Cartesian. And so it's a little bit less reliable. So if you're getting your first printer, you should go with the Cartesian system. And then the Polar printer and Skara printer are just here because they exist. They're not great printing systems, and so like printing movement systems. So I don't recommend them at all. So just start with the Cartesian system. You can use the Delta later on if you like it, but yeah, all my printers are Cartesian. So then the next thing that determines a 3D printer is noise level and software. So I don't have any pictures of noise level, but basically printers can be very quiet. Like you can have a printer in the same room and not tell it's there, or they can be very loud, like you can be 3 rooms away and still hear a 3D printer. And so basically their noise level is determined by their motor driver inside the printer and the motor they have. And this is a piece of electronic. So usually when researching this, you just search up how loud it is in like decibels and stuff. And there will be reviews on YouTube probably of your printer, of how loud it was. That's usually the best way to do it. And then the other thing you want to look at is software. So printers, like when you create a model, a CAD model, you need to use a slicer, which basically slices, like the name implies, it slices the 3D model into 2D layers for the print, because the print prints like draws lines, draws like a 2D model, 2D thing, like 2D shape or 2D design, and then stacks it on top of each other, stacks it on top of one another, like 2D layers over and over again to create a 3D model. So different printers have different like ways they do, like they print best at, and different like temperatures, different speeds, and a bunch of other stuff. So having like proper software for how your printer prints is a really good thing to have. So, and printers that don't can be very hard to work with, because you're going to need to tune the settings, and that can take a lot of time. And then, so next we're going to go over the printers I recommend. So these are at three different prices. So the Prusa i3 Mark III is the most expensive at $750. But it basically covers all of these points. Like it has any of the important aspects, it's always on the better side of them. So it has a direct extruder. It has a flexible bed. It has a sensor. It has a heated bed. It uses, well, all three of these use the Cartesian system. It's one of the quietest printers out there if you set it onto stealth mode and quiet, like at the lowest volume. And then it also has some really nice software developed for it, but it costs $750, and its build volume is 250 by 210 by 210. So the next printer that I'd recommend if you don't want to spend so much money is the Prusa Mini, which costs $350. And so it's basically a smaller version of the Prusa with a few like drawbacks. Like it uses a Bolden extruder, and it's not as stable, because you can see that Prusa has like two z-axes, and this one only, the Prusa Mini only has one. And then its noise level is so it uses a Bolden extruder. It still has a flexible and heated bed, and it still uses a sensor. And it uses Cartesian movement system. And its noise level isn't very loud if you set it properly. And the software is pretty good. And then, so the last thing you have is the Ender 3 V2, which has the biggest build volume, actually 220 by 220 by 250. It's a lot less reliable of a printer, and you can't print as detailed parts or use as exotic filament, but it's the cheapest at only $250. But it uses a Bolden extruder. It also uses a glass bed and manual leveling, although it still has a heated bed. It still uses Cartesian, all of them do. And it's a pretty loud printer, and you can't really adjust the noise for it. And the software is actually pretty good for the Ender 3 V2, just because of how cheap it is. A lot of people have used it, so you can easily find the required like slicer settings for it. And then the other thing you want to like when determining the printer is how long you're going to take to build it. So with the Prusas, you can actually get a pre-built version, just already built version sent to you, but that's going to cost a lot more. Like for the Prusa i3 Mark III, it's going to cost $1,000 to get the fully built version rather than the $750 build kit. And for the Prusa Mini, for fully built, it's cost $400 rather than $350. And these also both, if you were to build these on your own, they both take quite a bit of time. Like the Prusa Mini takes like 6 hours. The Prusa can take up to 10 hours. And so the instruction manual is good for these. So they just take a lot of time because there's a lot of things you need to do for building them. And then the Ender 3 V2 doesn't come with any pre-built versions, but it's a lot easier to build, only taking 1 or 2 hours to build, and it's pretty simple build. So that's also something you need to factor in when choosing a printer. So that's it for printers. So does anybody have any questions about 3D printers and choosing one? All right, so I don't think anybody has any questions, so we're moving on. So now we're going to talk about CAD. So basically, CAD is just taking anything like 2D, anything in your head, and building it on a computer, like and you can use CAD to 3D model so that you can use it to 3D print and CNC. And you can use CAD for a lot of other things, like simulating a part to see like where its points of failure are, and or its strengths, or creating something that has a lot of strength. And so CAD has a lot of applications. So we're basically going to go over throughout this class and the next two classes. We're mainly going to go over Autodesk Fusion 360. Basically, Fusion 360 is one of the more intuitive CAD programs, and it works well enough for what it does. It's best, it can simulate, but it's best known for its rendering ability, which we'll go over in the last class because that's a more complex thing. And it's basically it's like little brother CAD program is TinkerCAD, which is made by the same company. And so we're going to quickly go over what TinkerCAD is. So TinkerCAD is just a super intuitive CAD program that you're going to learn. Like if you take CAD class in middle school or high school, you're going to learn how to do TinkerCAD because it's the most simple one for teachers to teach. You don't need to download anything. You just need to search it up. And the teachers actually don't really need to teach you anything. You just drag in objects and then move them around. And that's how and then you can resize them using these different squares. But yeah, basically that's it for TinkerCAD. So it's very intuitive. You can do quite a bit of things with it, but for like accuracy, for very accurate parts, like trying to put this in the center of this cube, it can be very annoying to use. And it's usually just made for like quick fixes. Like if you want to remove a part, you can easily take like a cylinder hole and just like just drag it in and then you're done. So that's the only reason you would use TinkerCAD, for just quick fixes, and it's also very intuitive. But so then we're going to go over the CAD process. So the CAD process is just the normal design process. You brainstorm an idea, and then you usually want to draw whatever you're CADing on paper first. We're not going to do that today because we don't have the time. But basically, usually you want to draw on paper or something else first, or kind of like describe what you want. Because if you don't do that and you just start making it in CAD, you can spend a lot more time, and also you can be limited by your knowledge of the CAD program. So because there's a lot of things you can do in CAD, you won't necessarily learn how to do everything, and there's a lot you won't know. So you might just design your part around like the things you know how to do. And so you might not be able to design some like cool features that you really actually wanted that you would have drawn on the paper. So if you don't know something, just search it up, because there's a lot of information online. And then basically, yeah, you also, if the part is complex, you will also need to create like a process for testing like certain measurements and stuff. So that's it for the CAD process. So now we're actually going to get into CADing finally. So just open up Fusion 360. And if you have any problems with like downloading Fusion 360, just search it up. It can be a bit confusing and pretty complex getting Fusion 360 for free with the education license. But I think Fusion 360 has a lot of forums, so you just need to try some stuff out, and you will figure something out to get it to work. So All right. So once I'm just gonna go through everything, and I'm not going to necessarily wait for everybody to follow along because it's going to take too much time, I guess. So you can ask questions along the way. Um, so after Fusion 360 loads, the first thing you want to do is you want to click on your uh yeah, so the if you can create, okay, so someone asked, are you supposed to create your own team? And yeah, you can just create your own team. I think I created like the Master Builders team and I have a few people in it, but usually you just create your own team, at least for now. In the future, you can always change what team you're on and join another team. Um, all right, so the first thing you want to do is if you don't have this part showing up, you can like bring it out by show and hide data panel here, and we'll go over like what this is later. But the first thing you want to do is you want to go to your icon at the top right, and then you want to click on preferences, and then it's gonna take a bit to open up. Yeah, okay. Okay, so and then here you just there's a few things just want to make sure. So you want to make sure you're modeling Z up. And basically this just makes it so that when you if you were to export your print and import it onto a slicer, um, the print is standing up the way you CAD'd it, like with the top part facing up and stuff. And so because okay, and then so how Autodesk Fusion 360 works is you draw a 2D sketch or image, and then you either extrude it out and bring the 2D image straight up into 3D, or you there's a few other ways you turn that 2D image 3D. And so basically, because you start with a 2D image, sometimes like CAD programs can start with Y up because you can do 2D sketches. So because we're designing like 3D models, we want Z up. And then the other thing you want to change is your unit value. So you use whatever units you like to use and whatever you prefer. I for CADing, I like to use metric, standard metric units like millimeters, centimeters, and like kilogram, whatever. You can also use other like imperial standards, but I'm throughout these classes, I'm just going to use metric. And so that's it for the settings. It's pretty quick. And so first, before you start, you want to create a new project. And so this is just for organization, and then you can name it whatever you want for this class. So I'm just going to call it CAD Basics class stuff. Okay. And so and then for your first thing, if you already know what you kind of want to make, you can just save Control S. So you can go to File and click Save, or you can use the shortcut, keyboard shortcut Control S, and then you can save it into with a name like this. So the first one we're gonna do is called trap. Is basically just a trap ball in a cage. So I'm just gonna name it that. It's a pretty boring name, and then you just find the folder you just created, and then you save it. And then in CAD, there's many ways to do the same thing. Like there's like 10 different ways to probably do this. But I'm just going to go over what I find the most simple. So you can there's always another way to do this. So the first thing is you want to show origin usually. So if you click on any of these it'll get the plane, and this just makes things easier later on. You can, if you want to like look at just the model itself in the future, you can like disable showing, but I'll just leave it showing. And then the first thing you usually want to do is you want to right click on this name thing here on the left browser part, and you want to click on new component, and then you can name it whatever you want. But in this case, we're just gonna do the trapped sphere and cage. And basically, this just makes things easier to, it makes it easier to do some things later on and import like this part into another CAD design that you're working on, but it's just a good habit to have. You don't necessarily need to do this. You can just work on the CAD model without doing this, but it's just easier to do this. Like it's a good habit to keep. And so what we're going to start with is we're going to start with create sketch now that we've like done all the starting stuff. And so, like I said, we're going to make a 2D sketch and then we're going to bring it into 3D. So so we want to draw like basically a cube cage. And so we can do this multiple ways. We can use a 2-point rectangle and just draw a cage. But in this case, this just makes things easier. I'm just going to use a center rectangle and then draw it from the center origin and draw a 50 by 50 cage. And the reason why I draw a center rectangle rather than a 2-point rectangle is just so that the center of the rectangle is the same as the center of this origin. And that'll make, so when we draw the sphere will also start at the center of the origin. And so it will automatically be in the middle of the cage. You can also just draw like a 50 by 50 rectangle on the side. But when you create the sphere, it will also be like, it won't be in the center of the cage. And then you'll have to move it into the center, which is a bit more work. So we'll just then we can click finish sketch and we have a 2D sketch of a square. And basically now what we can do is we can click the entire face of the square until it's like lighting up blue. And then we can click the thing that makes it 3D. So we can click extrude and it extrudes out into a 3D object. So to create it into a cube, since we made the side lengths 50 by 50, we would make it 50, we would extrude out 50 normally. But because I wanted the origin in the center, I'm just going to extrude it 25 on this side. So I'm just going to type in 25. And then I'm going to extrude it 25 on the other side. So it's a bit more work, but this ensures that the origin, this like dot in the center, is still in the center. And someone asked how to place it in the origin. So if you go to here, you just do you see the circle in the center, that's the origin, and you just put your center point for your center rectangle into the origin. All right, so I'm just going to continue on. So now that we have a cube, we need to like put holes in it to make it more of a cage rather than just a solid cube. So how we do this is we're just going to make cube shaped, square shaped holes, and we're just going to do it on all sides. So we're again going to click one of the sides, and we're just going to click create sketch. And so we're again going to draw a 2D design and use it to cut a hole through the cube. So we're going to use center rectangle again, just to make sure this rectangle is also in the center. And we're just going to do a 40 by 40 square. You can make it a little bit bigger, like 45, or a little bit smaller. But I'm just going to go with 40 by 40. And then you can click extrude. And then if you go out, it will just extrude out a 40 by whatever, however much you extrude, like solid block. But since we're cutting, we go the other way. And Fusion 360 will automatically sense that you're extruding into another solid object, and it will automatically change the operation to cut. And you can actually still do a new drawing. And if you like go farther out, it can go out through the other side. But we're just going to use cut in this case, and we're just going to cut a hole straight through the side of the cube. And then we're just going to do the same on all the other sides. Okay. So if I'm going too fast, it's just you just click on the side and then you just go to create rectangle, center point rectangle, and then create a square in the center, 40 by 40, and then finish sketch, and then extrude it straight through both sides. and then just do that on all three sides. Okay. And so now we've created a cage. So then we're going to create the sphere in the center. So like I said earlier, there's multiple ways of doing things in Fusion 360. So you can, okay, so first we're going to just save the cage. Just we can name it, you can name it whatever you want, but you don't necessarily need to name it. And so now so if it's unsaved, like if you make like a change, there's going to be like a star next to it at the top, and that's just going to mean it's unsaved. So you can just do Control S to save it again. And basically, the next thing we're going to do is we're going to draw the sphere at the center. And there's multiple ways to do this. So you can Fusion 360 still has some TinkerCAD methods. So you can directly like import a sphere in the center and then size the radius. But we're just going to continue with the 2D to 3D method. And basically, we're just going to create sketch again. And then we're going to do it on one of these flat planes that define the origin. So for example, this one. And that way, if we create it, it's at the center of the cube, as you can see. And so the sphere will still be trapped in the cube. So what we then do is we click on the center diameter circle one, and we can basically click on this center point, which automatically Fusion automatically locks onto when you like go over it. And then you can just create a sphere, and then we're just going to do 50 millimeter diameter. And now we drew a sphere at the center. And then what the other thing we're going to do is we're also going to draw a line down the center of the sphere. And basically, what we're doing now is, so rather than extruding the sphere like straight out one side or another like we did with the cube, we're going to extrude it in a revolve style. So we're going to click on this revolve tool, and then so the face you want to revolve is this side of the sphere. And then the axis is this center sphere line that we drew. And we basically create a sphere. So revolve basically brings the 2D sketch and turns it around whatever axis you do. So for example, if the axis I chose was instead for example, this corner, then it will kind of create like this donut, semi-donut thing. So in this case, we're just going to revolve it around the center of the circle. And then we're going to revolve it a full 360 degrees to create a sphere. And so then we can just click OK, and now we have a trapped sphere in the cube. So does anybody have any questions about this?
How did you make the holes again?
So you basically, when you extrude it, so here, when you extrude it, rather than extruding it out, you can extrude it into the cube, and then it will say cut. The operation here will say cut when you do edit feature, like when you click on the face, the 2D sketch and click extrude, it will cut into it. And then when you click OK, you will like have a hole through it. Like if I go back, it will just show a hole. Like here, see, you'll have a hole. And then you can draw another 2D sketch to cut. Does anybody else have any other questions? No? Okay. So you write the dimensions. So someone else asked, so when you do the square, like how do you do the dimensions? So let me just pretend to delete this. Okay. one moment. So basically how you do the dimensions. Okay, actually, I'm just gonna leave that there. So how you do the dimensions is, so with the center rectangle, you find a point at the center and then you draw out like a square, and then you see that this number at the top here uh, is highlighted. Like you can see it, how I drag it will change the number, the highlighted number, and that's the dimensions. And so you can basically on your keyboard, because it's highlighted, whatever you input, like say I hit the key 9 right now, it will change it to 9. So whatever you input will become the new dimension. So if I do 40, and then for the other dimension, you just click tab and it will go to the other dimension. To go back, you just do shift tab. But to go to the other dimension, you just click tab, and then you can make that one 42, and then you get the dimensions. And then so someone else said that theirs isn't cutting. So when you do the extrude thing, if it's not like cutting, then you just change the operation to cut, and it should cut through the object. Yeah.
Did you make the perspective 2D? Like,
So you can click on, so when you create sketch, you can click on the plane and it should automatically go there. And if it's like
okay.
doesn't, you can click on the side that you're trying to draw on. Like this, for example, is the right side. So you can click on this side and you can also get it to a 2D perspective. And you can do that with any other side, like the top and then the left and the other sides. All right, so okay, so somebody still can't cut. So with extruding, there should be a cut option. Um, so I'm not sure the exact problem, but with extruding, there should be like the cut should just be there if you extrude into the block. I'm not sure exactly why it's not working. You can maybe just search it up. And then so someone's asking how I made the sphere. So you go, when you draw the sketch, you draw a circle and then you draw a line at the center, like intersecting the circle in half. So you do a centered circle with diameter 50 and you just draw it. And then you draw a line from the top to bottom, dissecting the circle in half. And then you click finish sketch. And then what you do next here after you're done with that is you use the revolve tool. So here, let me see if I can get it. Okay, so next, what you want to do is, so now that you have this sketch, here, let me make it shown. All right, so now that you have this sketch, what you want to do is you want to click the revolve, and then you want to click the one half face of the circle, and for the profile shown here, and then the axis, basically the profile is what you want to revolve, and then the axis is what you want this profile to revolve around. And so if you just do the center of the sphere, then it will just make a bunch of the half spheres go around in a circle, and you basically create a sphere like that. And so you just make it revolve around the center of the circle drawing, and then you get a sphere. And then you click OK, and then you have a sphere. Okay. So does anybody have any other questions? No? Okay. So we have 5 minutes left in class. So basically, I'll go over how to create the hexasphericon uh next class. So if the extrusion takes your entire shape out, you want it, so when you extrude, you want to click on this part you want to extrude. I don't know, maybe click on the entire like rectangular face, like this face. So you only want to click on the square inside and make sure that's the only part that's highlighted. The revolve is so somebody asked for me to do the revolve thing again. So again, it's just you just go you just have your sketch and then you click on the face you want to revolve. So you click on the revolve tool at the top left and then you click on one face you want to revolve. That's the profile. Then you go over to axis, you click select, and then you click on the center of the center line that we drew along with the circle, and then it automatically should create a sphere, and you want to make sure it's revolving 360 degrees around, and then you can just click OK, and it's revolved. So, all right, so yeah. So I'm just gonna go over the hexasphericon stuff in the next class. So I'm just gonna go over some other stuff you need to prepare for next class. So next class, we're gonna like go over how we create like logos and stuff and import it into CAD, or how we import kind of logos and stuff into CAD and images into CAD. So what you want to do uh, for next class is you want to prepare an SVG file, which is basically just a black and white image, like, and you want to prepare one like this Apple logo, like very simple, just or I guess this Batman logo works too, but or this Adidas one, but basically a very simple image that you want to import into your CAD design and then you want to use here. So that's what you want to prepare for next class. So does anybody have any other questions about this CAD design? Okay, so yeah, somebody asked if it's possible to draw 2D shapes line by line. Um, so yes, it is possible to draw 2D shapes. So somebody also asked how to draw a square on a square. So you can basically, okay, so let's pretend we go back like in history to like here. All right, so let's say we go back to the square. So to draw a square on a square, you just click the face of the square that you want to draw on, and then you click create sketch, and you can start drawing on this face of the square. And then to draw line by line, it's possible. So rather than using the center rectangle and creating a rectangle, you can use line or L, which makes you like click, is the same as clicking on the line tool, and then you can slowly draw out a square. So it's a 40 by 40 square. So you would draw like 20 out from the center just to make sure your square is centered. 20 out on this side, 40 out, 40 out, 40, 40 out, and then 20 in, and then you can draw line by line and create a square. It's just a lot more clicks and work to do. So usually you just use the center rectangle and then just draw a square like that. And then if there's no body to cut into, that might have to do with your preference settings, which can be different on like some other programs. So if you don't have a body to cut into, check like I don't know, the first extrude to make sure you're actually like extruding a solid object, I guess. Because sometimes it just extrudes out the walls. So yeah. So does anybody have any other questions? All right, so it's 7 now. So your basically only homework is just to find a black and white image, like only black uh, lines and a white black and white lines itself, like I guess this Nike logo, very simple. But basically find an image that you want to import onto CAD to use in an object. And so you want to do that for next week. So thanks everyone for coming, and see you all next week. And
Bye.
bye.
Thank you.
Thank you. Bye.